All right, this is the rest of lesson 3.6. Problem 4, we're going to solve a compound inequality involving OR. So what are the solutions to 2n minus 1 is less than negative 3, or negative 3n plus 2 is less than negative 4? And we're going to graph that. So 2n minus 1 is less than negative 3. We'll write them both down. Negative 3n plus 2 less than negative 4. Using the addition property of inequalities, I can simplify this one to 2n is less than negative 2. Divide both sides by 2. I get n is less than negative 1. Or we can subtract 2 from both sides on this one, and we get negative 3n is less than negative 6. Divide both sides by negative 3. And we get n is greater than, we had to reverse the symbol there because we divided both sides by a negative number. N is greater than 2. So our solution is n is less than negative 1 or n is greater than 2. We want to graph that.
Cassie Martin to the front desk, please. Cassie Martin to the front desk.
We'll put our number line in. And since both of these are less than, not less than or equal to, or greater than or equal to, we're going to put an open circle at negative 1. All numbers that are less than negative 1 are like numbers like negative 2, and so on. So that would include all those numbers. Numbers that are greater than 2 are numbers that are out here. One thing you'll notice about this graph is that we have arrows going in each direction. That means that a number will make this true if it's from this side or if it's from this side. So two different parts of the graph. All right, so here we'll try this again, solving a compound inequality involving OR. So it looks like we could subtract 7 from both sides. And then we get negative 6. Then we can divide both sides by negative 2. Notice they reverse the sign there. And we get y is greater than 3. Or subtract 3 from both sides on this one. And we get 4y is less than or equal to negative 8. Divide both sides by 4. And we get y is less than or equal to negative 2. And then we're going to graph it. It says hint, we'll use open dots, closed dots, or one of each. Here, we're going to have to use one of each. We're going to put an open dot on the 3. So let's see, 2, 4, 6, 8, negative 2, negative 4, negative 6, negative 8. So y is greater than 3. Put an open circle about where the 3 is. And put the arrow to the right for greater than. Put a solid circle on negative 2 and arrow to the left for less than. All right, one more thing from this lesson. We're going to use a thing called interval notation. You're going to use special symbols to mean including or not including. Brackets, use brackets to indicate that the interval's endpoints are included. Use either parentheses or the less than greater than symbol to indicate that the interval's endpoints are not included. So brackets mean they are included. Parentheses or arrows mean not included. For infinity, we're going to use sideways 8. For negative infinity, we'll just put a negative in front of that. And one thing you should know is that infinities are not included, since it really isn't a number. So, using interval notation, We'll just do a couple examples here. If I have a number like, say, -3, 1, and I write it like that, that can also be written as the inequality, where -3 is not included. So x is greater than -3, and x is less than or equal to 1. Okay, an example of something like 5, infinity. And you may see this symbol also for the end. That would mean x is greater than or equal to 5. The bracket means including that number. And if I wanted to say all real numbers, I could do that by just putting a -infinity to infinity in parentheses like that. That would mean all real numbers. All right, so using interval notation. The parentheses to the left of -2 means that -2 is not included. In -2, 7, the bracket to the right of 7 means 7 is included in the interval. So we're going to use those answers to write a compound inequality. And so the smallest number in this set is -2. -2 is not included, so we're going to just put a less than sign there. And the biggest number in this set is 7. 7 is included, so we're going to put less than or equal to symbol there. Then to graph that inequality, -2 is the smallest number. It's not included, so we're going to put an open circle there. 7 is included, so we're going to put a closed dot at 7, and we're going to shade all numbers in between. All right, a student writes the inequality x is greater than or equal to 17 in interval notation as 17 brackets, bracket 17, comma, infinity bracket. Explain why this is incorrect. Says circle the correct interval notation for the inequality x is greater than or equal to 17. So 17 is included here. So we need a bracket by the 17, and infinity is never included, so we need the parentheses for that. So the error was including infinity. All right, that's the end of the lesson. See you tomorrow.